Welcome to session 3 of the VPLEX Fundamentals. In this session, we're going to examine the key features and functions of VPLEX and how they can be used to support IT operations today. This session focuses on the capabilities of VPLEX and the most commonly used features. VPLEX Local consists of a single rack at a single site. The rack may contain 1, 2, or 4 engines, each engine containing 2 directors. The hardware is fully redundant to survive any single point failure. Each configuration can be upgraded to the next level, small to medium, medium to large, to linearly scale to greater performance and redundancy. VPLEX Metro consists of 2 separate rack sites with less than 5 milliseconds round-trip latency. Each rack may contain 1, 2, or 4 engines, each engine containing 2 directors. The VPLEX Metro makes it possible to configure shared volumes to hosts that are in different sites or failure domains. This enables a new set of solutions that can be implemented over synchronous distances where previously these solutions could only reside within a single data center. VPLEX Geo consists of 2 separate rack sites with less than 50 milliseconds round-trip latency. Each director has 2 10 gigabit Ethernet ports for inter-cluster communication over an IP WAN. VPLEX Geo extends the VPLEX Metro configuration to include solutions that can be implemented over asynchronous distances. Extent mobility is an EMC VPLEX mechanism to move all data from a source extent to a target extent. It is non-disruptive to any layered devices and transparent to the hosts using virtual volumes involving those extents. Over time, storage volumes can be fragmented by adding and deleting extents. Extent mobility can be used to help defrag the fragmented storage volumes. The data on devices can be moved to other devices in the same cluster or remote cluster in a VPLEX Metro. The data mobility feature allows you to run up to a total of 25 extent or device migrations concurrently. The system allocates resources and queues any remaining mobility jobs as necessary. Mobility Central provides a central location to create, view, and manage all mobility jobs. Batched mobility provides the ability to script large-scale mobility operations without having to specify individual extent-by-extent or device-by-device mobility jobs. Batched mobility can only be performed in the CLI. Use batch migrations to retire storage arrays for off-lease arrays and to bring new arrays online and migrate devices. A distributed device is composed of 2 local devices that exist at each site and are mirrors of each other. Read and write operations pass through the VPLEX WAN. Data is protected because writes must travel to the back-end storage of both clusters before being acknowledged to the host. Metro offers synchronous updates to the distributed device, while Geo offers an asynchronous method to allow for greater distance between the sites. Distributed devices are mirrors that clusters will share in a VPLEX configuration. In order to create a distributed device, a local device must exist at both sites. This distributed RAID 1 device is created upon the 2 local devices and can only be as large as the smaller of the 2 devices. Consistency groups aggregate volumes together to ensure the common application of a set of properties to the entire group. You create consistency groups for sets of volumes that require the same I/O behavior in the event of a link failure. In the event of a director, cluster, or intercluster link failure, consistency groups prevent possible data corruption. The optional VPLEX witness failure recover policies apply only to volumes in consistency groups. Before you create a consistency group, consider how it will be used. Is the cluster latency greater than 5 milliseconds? Will the consistency group contain volumes on distributed devices? What is the visibility of the virtual volumes to be added? Some properties of virtual volumes and consistency groups limit which volumes can be added to a consistency group or prevent a property of the consistency group from being modified. Here's an example of the migration process using VPLEX. VPLEX is installed and the appropriate storage in the environment is virtualized by VPLEX. Virtual volumes are assigned to the host, taking into account application and system high availability requirements. This prepares the environment for the arrival of a new array. When the new array is presented and installed, VPLEX copies data in the background. No external tools running on the hosts or the array are required. Once the data is copied to the new array, VPLEX can now non-disruptively link the servers to the new array. No outage takes place during this process. Also, it's fully reversible. The VPLEX can just relink the servers to the old array if performance or other factors dictate a rollback. This can all be done in less time because no outage scheduling is necessary and all the work can be done during work hours. This session covered the topologies, features, and capabilities of VPLEX. We looked at a description of the VPLEX key features and capabilities, a list of the topology features, and how to identify the key features and capabilities used in an IT environment. This concludes the introduction for Session 3 of VPLEX Fundamentals. We reviewed all of the components that are available and features that support IT operations. Now it's time to go ahead and to answer the question within the discussion forum for this week. Be sure to answer at least 2 of the other members of this course to give them ideas, guidance, corrections, or just general discussion about VPLEX features. Thank you.